Hello students, in this video we're going to use what we've learned about limits and critical values to analyze certain functions. So first of all, let's recall what critical values are. Let's say I have a function y equal to x minus 1 times x minus 2 quantity square times x minus 3. What would be the critical values of this function? Let's recall the definition of a critical value. A critical value is the value of x where the function would either cross or touch the x-axis. Okay? So what would be the value of x in this case for this particular function? What would be the value of x that would make this function either touch or cross the x-axis? Well, it would be x equal to 1, right? Because when x equal to 1, it would set the whole function equal to 0. Similarly, at x equal to 2, you will also set the function to be 0. And finally, at x equal to 3. So these would be the critical values of this function. Now let's take a look at another function. Okay, another example. Let's say I have a function equal to x squared minus 3x plus 2. So we recognize this is a quadratic, and because the coefficient in front of x squared is a positive number, so I can kind of guess the function probably should look something like this. It's facing up, right? But I don't know whether it's going to cross the x-axis or where, for that matter. Right? All I know is this is a quadratic and it's going to be facing up. Well, we have to do some further analysis to find out where is the function located, right? So I can do a completing the square operation and I can make it into y equal to a times x minus b squared plus c. I can change it into that form, in which case it would readily show me where the vertex of the parabola is, as well as what is y offset. Okay. Another way I can do this is I'm going to factor this if it's factorable. So how would I factor this x squared minus 3x plus 2? So I recognize that it is minus 1 and minus 2. That's going to give me minus 3x. And that's the middle term. And then I have minus 1 times minus 2 is equal to plus 2. Now that it's in factor form, it's much easier to see where the critical values are, right? Critical values is where the f of x or y is equal to 0, right? And where's y equal to 0? Well, it's when x is equal to 1 or x equal to 2. So I know now that the actual curve that I'm going to plot in blue is going to look like crossing the x-axis at 1 and 2, and since it's facing up, the only way that parabola can do that is it's going to look like this. Okay? Let's take a look at a third example. My third example is y equal to x squared minus 3x plus 2, which is actually the same as the previous one, but I divide that by x minus 5. Now what would be the critical value of this function? Well, let's factor the numerator out like what we did before. So this becomes x minus 1 times x minus 2 divided by x minus 5. Okay. So here we have one more critical value that is different from previously. So critical value is where the function crosses the x-axis. In other words, that's called a zero of a function, okay, or the root of a function. So in this case, y indeed has zeros at x equal to 1 and x equal to 2, okay. But what happens at x equal to 5? when it's x equal to 5, I actually have a vertical asymptote, right? Because when x is equal to 5, the whole denominator becomes 0, and that would make the function to increase to infinity, okay? Either infinity or negative infinity. And so the vertical asymptote is another one that we need to add to the list of critical values, okay? A vertical asymptote is also, you may recall, also called an essential discontinuity, okay? So what would that look graphically? Well, I'm going to have zeros at 1 and 2, and I'm going to plot those using blue. Okay, I have zeros at 1 and 2, so 1 and 2. That means I know the function is going to be crossing or touching the x-axis at those 2 points. At the same time, I know that it's going to go to infinity. It's going to become very, very large at x equal to 5. So let's say x equal to 5 is out here. Okay, it's going to have a vertical asymptote at x equal to 5. Okay, and the function, which I'm going to draw it in purple, is going to cross the function somehow. Okay, I don't know which way it is yet. It could be positive or negative. Okay, and then it's going to be crossing over the x-axis at 1 and 2, and then it's going to reach infinity or negative infinity as x approaches 5. Okay, and in the next video tape, we're going to examine exactly how we can use those information plus some others in order to actually plot out the graph and analyze the behavior of this function.